Hi everyone, I am Korneel Rabaey from Ghent University in Belgium, and I'm truly honored to kick off this introductory session for the Water webinar series today, together with David Sedlak. Benjamin Franklin is attributed to quote, "When the well is dry, they know the worth of water." This quote is very apt today as water supply and quality have in the past years become an increasing societal liability. Whether we find ourselves in areas with large population growth or in areas suffering from decreasing or more variable water availability, we're all getting more and more aware of the fact that water cannot be taken for granted. It is interesting to consider, though, that there is today as much water on Earth as there was yesterday. Well, give or take the 30 cubic meter or so that goes in space every day. It's thus a matter of distribution and quality and not of quantity. Those liabilities force new models for local robustness to evolve, and we're in many places moving away from the old paradigm that connecting is solving and move towards concepts such as water-sensitive cities. New technologies intervene at building and urban planning levels. With top material science, engineering, biotechnology, space science coming into the water field. New business models and governance arise following opportunities often created by regulatory developments, and the increased complexity created by these new developments requires new means of dealing with data and monitoring in different ways. The complexity also raises ethical questions regarding water rights, water availability, and potentially individualized quality. And the answer to these questions is very dependent on where one finds him or herself, as today's key speaker will soon address. Improved water supply opens opportunities to empower women and children, to increase productivity and to increase schooling. And water has always inspired, but the perspective is always changing. When we as engineers and scientists deal with this evolving front, we typically do this from a monodisciplinary way. Now, if you want to work on a sustainable water future, you need to understand different viewpoints and consider the impact of different disciplines, how they have an impact on your work. Now, to contribute to such an awareness, the University of Ghent, the University of Queensland and the University of California, Berkeley have teamed up to create a webinar series covering very different aspects of water to provide a more comprehensive view for workshop attendees and mainly to inspire new ideas and insights. Kicking off the webinar series today is my co-organizer Professor David Sedlak, currently Plato Malozemov Professor at UC Berkeley. He was previously Editor-in-Chief of Environmental Science and Technology, and I'm sure many of you know his book Water 4.0, in which he very eloquently discussed past and future of water. He is the ideal person to provide this umbrella overview we need to start our series, to start our journey. And with this, I very gladly pass over to him.
Hello, everyone. I want to welcome you to the Water webinar series, a collaboration between Ghent University, the University of Queensland, and the University of California, Berkeley. We felt compelled to initiate this series because we think it's time that the world rethinks the way in which universities conduct research related to water. You see, at the time that the modern university was built in the period after the Second World War, the world's population has expanded threefold. A web of information technology and global trade connects us in ways that we never could have anticipated back then. And as a result, the way in which we think about problems and the way in which we solve problems is interlinked. And so the old way of thinking about a university as separate colleges and departments where people worked on small areas. In fact, the old way of thinking of separate universities that only worked on problems relevant to their part of the world is rapidly disappearing. And nowhere is this more clear than in the world of water. So in this seminar series, we hope to break down some of the barriers that prevent us from solving some of the hard challenges facing us when it comes to water. we hope to open lines of communication by bringing people together who have expertise in specific domains and having them share that information in a way that's accessible to someone who hasn't necessarily had training in that area. And so this particular webinar or this talk that I'm giving today is really intended to introduce the purpose of the series and to show you ways that we're linked together that you might have not anticipated before. I call the talk the water inflection point because, as you'll see, inflection point can refer to a mathematical function and the change of slope, or it can refer to a change in the way things happen, a rapid change that brings about a new state of action. And I think us as researchers would like to find ways in which the things that we can do can contribute to a change that will help the world address some of its big problems. Now, when we came together and came up with a schedule for the series and started thinking about how we would organize it and what topics we would cover, it was decided that the series would start with a historical perspective on water. But when I sat down to think about how I could present a historical perspective on water, I realized that many of the things that I would have wanted to say, I've already said in other formats. And so we've already been many of the places that maybe we'd like to go when it comes to talking about water, and I don't want to waste your time. So one of the wonderful things about the new way in which we can have webinars that are pre-recorded is that you can pause your machine and go and have a look at something that's already been said. So if you want to hear what I might have told you about the ways in which we obtain water in big cities around the world, you can look up this TED Talk I gave a few weeks ago. You can hit the pause button, spend 11 minutes looking at this, and then come back and understand what I would have said based upon that seminar that I gave 4 years ago. Or if you have more time, instead of spending 11 minutes, you could spend 11 hours and listen to the audio book of Water 4.0, a book that I wrote in 2014 to try to explain some of the water issues that I've been addressing in my own research. And that perspective that I had in the period of about 2014 was really based upon the first 2 decades of my career at UC Berkeley, where I'd been thinking about issues related to water that pertain to parts of the world that were wealthy and undergoing water stress, like the Southwest United States, like parts of Australia or Singapore or the American Southeast and Southwest. But it wasn't thinking about the whole problem that the world faces when it comes to water. And so as part of my continuing education, part of my attempt to keep growing in these areas, I've looked deeper into the issues facing the world when it comes to water. And I think if I had a history to tell you, or was going to rewrite that book or give you a different kind of TED Talk, I wouldn't limit myself to the water problems facing the world's big cities. I would talk about the 6 water crises facing the world. And these 6 water crises that you can see here are interlinked. They're not necessarily distinct from one another. That is, different places can be experiencing different crises at the same time. So for example, a place that doesn't have enough drinking water might also not have enough water for growing food, or might not have enough water to support healthy ecosystems. So they're not exclusive to one place. But I think when we start to think about the world's water crises as being separate from one another and having different underlying causes and possibly different paths for solution, we start to see the way in which we can learn from one another and the way in which we can address the problem separately and develop tools and skills that then can be applied in a different context where perhaps the financial resources are different, or the nature of the problem and its solution will be slightly different, but can still learn from the other ones. So what I want to do here is I want to take you briefly through the 6 water crises, because I think as you go through this seminar series and start seeing the other speakers talk about the areas that they're passionate about, you can see that much of what they do fits into one of these 6 bins of different types of water crises. And you'll see that they're all ultimately tied together in some way or another, but the solutions may only apply in certain geographic regions at certain times. So let me run you through the 6 crises, starting by thinking about the way in which people obtain water. So if you want to think about the global income distribution, it's a wonderful way to think about the first three water crises. So this is a figure that was adapted from the website Gapminder, which was started by Hans Rosling and his family. And what it does is it tries to depict the way in which people live around the world through these little schematics. And the schematic below breaks the world up in terms of income level. And you can see it's a logarithmic scale where there are 4 different levels of income. And each of those little symbols below looks like maybe a playing piece that you might have in a game representing a person. Each of those little icons represents about 1 billion people. And so you can see there are about 1 billion people in level 1. These are people who live on less than $2 a day. There are about 3 billion people in low income countries represented column level 2, about 2 billion in middle income countries between $8 a day and $32 a day income, and finally about 1 billion people in level 4. And the photos above are just examples that maybe would remind you of the way in which people in those different income levels obtain their water. So those of us who are fortunate enough to live in level 4, the wealthy countries of Western Europe, North America, Oceania, and parts of Asia generally get piped water coming into our house, delivered 24 hours a day, 7 days a week, and it's usually safe to drink. Level 3, you might not want to drink the water directly out of the tap, but you'd probably have a separate source of drinking water that would come to you, maybe bottled water of some kind, or a truck would deliver the potable water to your house. And then you'd have flowing water that maybe wasn't necessarily safe to drink without some additional treatment. People who are in low-income countries who fall into level 2 might have access to piped water, but it wouldn't necessarily come into their homes, and it might not be available 24 hours a day. And finally, people in level 1 are characterized their water access by having to go through a considerable amount of effort to obtain that water. So if you want to start thinking about the different ways in which people obtain water based upon income, it helps us see the first of the 3 crises. So the first crisis, which I call the water for the wealthy, is the one that I wrote about in Water 4.0. And this is the idea that people in rich countries occasionally experience water shortages due to either overexploitation of water or drought coupled with population growth. And so these are the kinds of problems that have been experienced in the western part of the United States and in Australia, and even happen from time to time in Belgium. And they're the kinds of things that we tend to address with a combination of technology, whether that's seawater desalination or water recycling, and policy measures like ways of enhancing, getting people to conserve more water or use water more efficiently. And so I think many of the people watching this webinar are well acquainted with that, because people working at universities tend to focus on the problems facing their region of the world or their particular country, because that's where a lot of the government funding originates. I would say the water crisis for the many, the drinking water for the many, the 5 billion people in the middle, is in many ways the place where folks at the university pay the least attention. And that's because this is something that we just assume is going to happen, because people aren't necessarily living in abject poverty. And when we travel to these countries, we can see that people have water supply. But if we stop and think about it and think about the growth that's coming around the world, you'll see that the world is going to invest hundreds of billions of dollars or even trillions of dollars in building water infrastructure for rapidly developing cities, whether that's in Asia and Southeast Asia or Sub-Saharan Africa and South America. In the coming 30 years, that's where a lot of the growth is going to happen. And the people living in these places right now are being told they should grow up their water system by building infrastructure that looks like the infrastructure of people in the wealthy countries. And that may not necessarily be the right choice, because those of us who have experience in these wealthy countries know that our water infrastructure may not be well suited for getting us through the 21st century. So why would we want the 5 billion people coming up in increasing income to replicate the experience that we've just gone through and that we struggle with trying to change on our own? And finally, drinking water for the poor, the third of the water crises that I mentioned, is the one that's most closely related to Sustainable Development Goal 6, the one that many people at universities think about when they think about the question of access to water and sanitation for the world's poorest people. And this is a problem that I think we'll hear about somewhat in the webinar series, and an area in which is quite challenging given the low resources available and many other challenges that people face trying to build that up. So those are the first three of the water crises. The fourth water crisis is one that transcends income. It's drinking water that's healthy. And I wanted to use arsenic as an example because it's probably best known to people in our field. And so most of us are well aware of the crisis of drinking water that's contaminated with arsenic. And the place where we probably know the most about it is the situation in Bangladesh. So in Bangladesh, the surface water used to be the main drinking water supply, but it led to severe public health problems because the surface water was contaminated with waterborne pathogens. And so a well-intentioned effort led by United Nations and other NGOs led to the installation of tube wells. And tube wells were simply shallow wells that allowed people to get water that was filtered through the soil. And that meant it had fewer waterborne pathogens in it. But unfortunately, the people involved in that effort didn't realize that the groundwater, the shallow groundwater in the plain where the Ganges River had discharged was rich in arsenic. And so that drinking water was contaminated with arsenic. And so something like 30 to 60% of the population of Bangladesh was drinking water at concentrations above the arsenic health standard, and it was becoming evident that people were becoming sick. Now, Bangladesh isn't the only place in the world where this is a problem. I think it's been well documented now that Vietnam and parts of other parts of Asia and South Asia had severe arsenic problems. But when people came and tried to solve these problems that they were encountering in tube wells and hand pumps, the technologies for point of use treatment were found to be severely lacking. So here's two examples of the kinds of technologies that researchers from universities tried to transmit to communities in Bangladesh and other places. And they generally involve some sort of relatively simple physical method or chemical method for absorbing the arsenic and removing it before people drank it. And these technologies worked quite well in the laboratory, but in the field, they failed for a variety of reasons related to the complexity of the system and the way in which new technologies are assimilated or not assimilated by people from other cultures. And so today, probably the most effective means of reducing arsenic exposure in places like Bangladesh is to paint the wells that have high levels of arsenic red, and the wells that have low levels of arsenic get painted green, and people have the option, when they're given some education, of avoiding the contaminated wells and lowering their exposure to arsenic. But it shows kind of the failure of our research community and the professional development community to come up with a point of use water treatment solution that was effective. Now, the problem of arsenic in Bangladesh is not the only place where arsenic's a problem. For example, in the United States, there are over 2 million people who are exposed to elevated levels of arsenic. And most of that arsenic exposure comes from household wells or community wells where it's too expensive to install point of use treatment systems. And so there's a commonality there that transcends economics, where we haven't figured out a way to make practical the promise of effective, trouble-free, maintenance-free systems for protecting people from contaminants in water. And of course, arsenic isn't the only problem. It's been estimated that somewhere around 200 million people worldwide are exposed to elevated levels of fluoride as well. So in addition to the waterborne pathogens that are frequently in people's water, which are removed by chlorination and water filtration, there's this problem of contaminants in water. And we could go on and on talking about things like the PFAS chemicals or other kinds of organic chemicals that find their way into tap water. The point here is that we haven't figured out a way to avoid these crises. And when they're discovered, they really are crises because people lose their water supply. So the first four of the water crises are related to drinking water. The first three are separate based upon the income level and the type of infrastructure that people have. The fourth one is related to contaminants, and I gave you an example of arsenic, but there are others, and that transcends all kinds of income levels. The fifth of the water crises is having enough water for food. And I think we're all familiar with this challenge of water supply for food. But if you think about it, over the next 30 years, the world is going to have to grow 70% more food just to support the growing populations and the increased standard of living that people have. And this is going to be quite challenging because we're already not using our water in a very sustainable manner. So this is an example. This figure shows you the groundwater level in a part of India, Gujarat, from the period from 1976 to about 2009, and what you can see is the level of the groundwater has been falling consistently. And it's been falling consistently because technology provided a cheap means of exploiting groundwater. Basically, the submersible pump made it inexpensive to pump groundwater, where previously it took a lot more effort to get water out of the ground. And so parts of the world, including India and China and the American West, have been overexploiting groundwater in an effort to grow more food. And when you look around the world, you can see many places where the irrigation systems that were part of the agricultural revolution that increased food production around the world are no longer able to deliver the amount of water that people expected them to, either because of changing climate or because of over-extraction of resources. So we really have a potential crisis facing us as these unsustainable water use practices start to lead to an inability to grow food. So that certainly will be a crisis. And then the sixth of the water crises is water for the environment. And I illustrate it here with this famous set of images from a NASA satellite showing you the shrinking and near disappearance of the Aral Sea in Central Asia. And the reason that the Aral Sea disappeared is that it's a terminal lake, so it receives water coming in from outside sources, and the size of the lake is determined by the balance between the water flowing in and the rate at which it evaporates. And prior to the great expansion of agriculture in the region, the Aral Sea had a relatively steady size, but as more and more of that water was diverted primarily for agriculture, it shrank and virtually disappeared. And so terminal lakes around the world are the most graphic example, perhaps, of not having enough water for the environment, because the aquatic environment basically disappeared in this case. But it's not the only one. There are many places around the world where overexploitation of water, water being diverted for human uses, particularly agriculture, has strained aquatic ecosystems. And then there are many places where pollution coming from human activities, again, agriculture and cities and industrial purposes, has put strains on ecosystems. Everything from the dead zones around the world, like in the Gulf of Mexico and many of the other estuaries around the world, to the polluted rivers that we're all familiar with. And so certainly when that hits your country, it is a crisis. So those are the 6 water crises. And maybe before we turn our attention to the solutions, we should give a little bit of a thought of where we're going and what the trajectory looks like for the next 30 years. So one element of the water seminar series that I think it's very important to keep in mind is this idea that we are in the midst of the Great Acceleration. And the Great Acceleration is a shorthand way for describing the changes that came about starting in about 1950 and that continue today. And if you've never looked at these figures or any of the figures like it, it's really worth spending a little time thinking about the changes that have occurred during this period, not only around the world, but to break them up into the regions of the world where they have occurred. So these are the 12 famous graphs of the Anthropocene, or of the Great Acceleration, starting in the upper left-hand corner with population growth and ending in the bottom with international tourism. And I think they tell a story for us about an exponential growth in not only people, but wealth and the way in which we've exploited the environment. And then what's also evident in these figures, if you look a little more closely, is that the OECD countries, or the wealthy billion people of the world, that population growth and economic expansion and resource exploitation is starting to level out. And over the last 20 or 30 years, I think we've all experienced the rise of China and now India, but the BRICS, the Brazil, Russia, India, China, and South Africa are really important with respect to the current situation. But I think increasingly in the future, if you look at these figures, you'll see the top of those three different colors gets even more important as those other countries, in particular the countries of sub-Saharan Africa, start to grow and require more water and food and fertilizer to maintain their standard of living. So this is kind of one of the underlying themes that I think we have to consider when we think about the world's problems and how university research might help address them in the coming decades. And then the other driver of a lot of what we're going to experience over the next 30 years and in the second half of the 21st century is related to climate change. Now, maybe 20 years ago when we talked about climate change, we had hypotheses and some ideas about how a changing climate would affect water use around the world. But now it's becoming more and more evident as we see cases where changes in ocean currents and atmospheric circulation patterns are affecting water budgets around the world. And one of the places where we've learned a lot about that is in Australia, where expansion of the Hadley cells has changed the storm tracks in the wintertime. And a lot of what's happened in the past decade or so with respect to the area around Melbourne and the area around Perth with respect to precipitation patterns and yields in reservoirs is related to changes in some of these atmospheric and oceanic circulation patterns. And so in general, we expect the impacts of climate change on water supplies to accelerate in the future and make it harder to run the infrastructure we have, and in many ways, hard to create new systems to collect water and manage it effectively. So with this, we find ourselves at what I'll argue is an inflection point. And if we turn to Google for a definition of what an inflection point is, we can certainly think about the mathematical curve, and you can look at the curves from the great acceleration and see that in some ways we're starting to anticipate the great deceleration, where the rate of population growth and the rate of resource exploitation will slow down and maybe even reach a place where it's flat or declining. But I'm more inclined to think about the second one, the idea that we're at a place where a turning point is possible. And there's no guarantee what direction that turning point goes in. It could go in the wrong direction, where we have more and more water crises affecting more and more people in the future. But we as university researchers want it to go in another direction. We want to try to change the way in which the world uses water so that we can all benefit from having fewer water crises and achieving the kinds of things that we want to achieve. And I think the goal of bringing us all together for these discussions is to see how each of us working in our own specialization can contribute something to a more holistic solution to the world's water crises. And so when I think about the solutions for the 6 water crises, recognizing that each crisis has a different set of solutions and each place has a very geographically distinct set of drivers and possible solutions for these things, I see 3 paths. And I think we can lump a lot of what we're going to talk about during the webinar series into 3 different paths. And these different paths are the places where there are opportunities. And I'll argue today that the 3 paths are all required because the magnitude of the challenges that the world faces with respect to water cannot be solved by one path alone. So let me tell you about the first path. The first path is efficiency. The idea of doing more with what we have, because we may not have more, or we might have to share the water that we have with many other people. And to give you an example of the power of efficiency, I want to share this figure with you. Has nothing to do with water, it has to do with electricity. And what you see here in this plot is per capita electricity consumption in the United States from 1970 to about 2010. And you can see a divergence between California and the rest of the United States. So in the period from 1970 to 2010, we brought a lot more electricity into our lifestyles. We had the growth of the internet. We changed the way we lived and worked. People, as they became wealthier, lived in larger houses. Air conditioning became more important as a way of cooling homes. And yet California's per capita electricity use remained constant, while the rest of the United States almost doubled. Why was that? Well, a lot of the credit for this goes to a scientist named Art Rosenfeld, who was at UC Berkeley and then later helped run the California Energy Commission. But Rosenfeld, among other things, popularized the complex fluorescent light bulb. He also worked on energy efficiency standards for refrigerators and air conditioners and other types of appliances. And he helped the state chart a course to reduce electricity demand during a time when the rest of the United States kind of ignored this as an opportunity or only did the minimum of it. And so there are opportunities for us to have the same sort of impacts that Rosenfeld had by reducing water demands without compromising, because the quality of life of people who were using electricity in California was not compromised by the adoption of efficiency. In many ways, they ended up saving money in the long run and having fewer power plants needed to support their lifestyle. And so I'll just show you a figure here from the world of water, which maybe serves as a bit of a teaser. I think since so many people in our audience think about urban water, I wanted to think about the issue of household water use, very similar to what Rosenfeld's data was. It's per capita residential water use in liters per day. And I've broken this up. On the left, you'll see Europe. In the center, you'll see North America. Then you'll see Asia and Oceania, and then you'll see South America. And I think there's a lot to talk about here, because clearly there's a big difference between North American cities like Los Angeles and New York and Phoenix. But there are even places like Mexico City and Buenos Aires and Taipei that experience water shortages and yet have per capita household water use that's 3 times as high as some European cities. Why is that? Well, it's a combination of many things. It's not just purely a question of economics. It's not just purely a question of how cities are oriented and the population density. It has to do with demographics. It has to do with climate. It has to do with the technologies that people use to run their water systems. And to figure out just how far we could go in terms of household water use efficiency and the best approaches for achieving it, it's going to require collaboration between social scientists and technologists and people who think about communication with the public and public perception of what water efficiency means. The second path for solving the world's water problems comes from the area of technology innovation. And so there are researchers at the university who make it their job to think about innovative technologies. And the idea that we can make an innovative technology that would help solve some of the water crises that the world faces what keeps us going. It's the same thing that got people going in the early 1960s. You can see this quote from President Kennedy's 1961 State of the Union address, where he was pushing the idea of seawater desalination as a contribution that the United States could make as part of its effort to win people over during the Cold War. In fact, some people would say that if Kennedy didn't get wrapped up in the race to send people to the moon, they might have invested even more money in desalination. But a lot of money was invested in seawater desalination in the early 1960s. And some of that money that was invested led to the initial development of the reverse osmosis membrane. And today, we're still reaping the benefits of that technological innovation as the reverse osmosis membrane has undergone the movement from the laboratory to become a stable industry. And you can see here in this figure, the growth of seawater reverse osmosis from 2010 to 2016. Basically, seawater reverse osmosis is almost doubling every decade. And so where we might have a few 100 million people receiving their water supply from seawater desalination, if current trends continue, by the year 2050, we could have close to 1 billion people obtaining their water from this technology as it becomes less expensive and as the technology matures. So in this audience, there are people thinking about technological innovations, and they can play a role not only in desalinated seawater, but desalinating brackish water, recycling wastewater, and making it possible to improve the efficiency of many of our treatment processes. And finally, the third path, and a path that is really intriguing to me and many of the people who'll be participating in this webinar, is the idea of redefining relationships. And by that, I mean thinking about our relationship with the environment and the water that comes out of the environment, because ultimately sacrifices may need to be made in terms of how much water people take out of the environment and how much resources we spend in purifying and cleaning and recycling water in the long term. And so in this respect, it really raises the question of what do we do with technologies and how much energy do we put into realizing efficiencies? And when we realize those efficiencies, do we just plug it into using more water, or do we start returning that water to the environment? And one thing that captured my attention a few years ago and that I've been thinking about is that the way in which people think about their relationship with water and the environment differs in different parts of the world. And so you can see that in 2017, a Maori tribe in New Zealand won a lawsuit which allowed a river to be recognized as a living entity. And that was consistent with their culture. And because of the way the New Zealand Constitution is written, it was possible to find standing for a river as a legal entity. And that means that the way in which that water is taken out of that river and the way in which pollutants are introduced into that river has to be considered in a different way in the future. So we don't all necessarily have that kind of legal framework, but we do have the possibility of raising people's consciousness about the moral obligation that we have to the environment, as well as the moral obligation that we have to future generations to protect the environment and make sure that the planet is a place that they want to live on. And so I think about my own experience here in California, and I see parallels to the experience in New Zealand in the Mono Lake decision, which is a very famous legal case, which basically took the water that the city of Los Angeles was exploiting from the eastern Sierra Nevada mountains and required that it return to Mono Lake, a terminal lake in the desert that was drying up just like the Aral Sea because the water was being diverted for urban uses. And the legal basis for this decision was something called the Public Trust Doctrine, which is an element of English common law, which had been adopted in California in its constitution and water rights framework. But it basically says that just because someone has a property right doesn't mean that that property right is available forever, especially if using that property puts at jeopardy the welfare of others in the society. And so I think that when we hear from people about the way in which art and literature and other types of communication can be used to raise public consciousness about water, this idea of redefining relationships and how to do it will always be in my mind during this series. So in summary, I want to share just a couple final thoughts with you as we move on. I want to first say that I think that there are many problems facing the world, many different water crises at our doorstep, and we as university researchers are anxious to apply ourselves to help solve them. And to me, it's evident that the problems are so big that we really need an all of the above approach if we hope to get over that inflection point and create the water systems that we all hope take us through the 21st century. I think that in order to do this, we need to pioneer a new type of understanding that transcends academic disciplines and even transcends our home universities. We need to create a community of scholars that's willing and able to take the time to communicate what they know and even make mistakes as they try to understand the challenges that are outside of their narrow band of expertise. And I think we hope to start those conversations to get us in that direction. And finally, I want to leave you with the thought that water is a reflective medium, and it really reflects who we are as human beings and what we are as a society. And so it's worth putting the extra effort into making sure that we get water right, because it's related to so many other things that we have to try to get right if we want to make it through the 21st century. So thank you for your attention. I look forward to the webinar series. I look forward to discussions with all of you, and hope to get this started off on the right note.
Thank you very much, David. I'm sure everyone agrees that you got us off on the right note to start with this webinar series. I want to take the time to go a little bit through the schedule and introduce a few practical aspects of how this is going to work. Now, we have brought together excellent speakers covering different themes, from history to technology to practice, in the coming weeks. So we'll start with the first webinar on January 7th, which is called Water Flows Across Time, where we're going to look more at the history. We're going to look backwards a little bit. And the week after, we're going to look forward in different ways. On the January 14th, we'll be discussing small-scale technology and the associated data that comes with this. And the week after, we'll rather dig into larger scale technology and also technology deployment and water systems in remote areas. And January 28th, we're going to go to water in practice, looking at how loops are closed within the city and making more robust regional water systems. Then February 4th, we'll talk about a very well-known topic, water and climate, greenhouse gas emissions and how climate change affects water availability, and move on to architecture, how we are living with water and designing our systems to deal with a more sustainable water cycle. And then February 18th, we hopefully get a lot of inspiration from water through the artists participating in our program. Someone has to run it, so we're going to talk water governance on February 25th, how to close this whole water cycle and how to manage it. And then on March 4th, we'll be discussing water power. What are the social implications of water and what happens when the trust in water runs dry? We're thinking of setting up a final session on March 11th on a topic called the resource, which is water. Now, practically, make sure you register for the different sessions that you're interested in online. You have to click them individually. Let's hope we can solve that in the course of the program, so you can in one go register for everything. And each time there's a webinar, there's going to be 2 talks, followed by 2 debates between the speakers and the panelists. And so you can follow the webinar either at 4 p.m. your time on the dates that I just indicated, or you can watch later on YouTube. Now, before finishing up today, I do want to thank all the partners, Ghent University, who also funded the initiative initially through these strategic institutional partnerships, together with Berkeley and with the University of Queensland. I also want to make an ad for Capture here, a center on resource recovery with a big focus on water as well. And I want to thank Environmental Science and Ecotechnology, the new journal, particularly Yu Tao, who is facilitating getting this webinar series broadcasted in China as well. With that, thank you for listening to us today. I'm sure you're as excited as I am about David Sedlak's great talk and the upcoming water webinar series. And I look forward to hearing all the feedback in the coming weeks and months. Thank you.